the doubts of worksheet number 3. So, right. I will discuss most of the questions. So let's quickly look at a review of the concept of components of vectors. So what we saw is that we have seen only in 2 dimensions so far. What we saw is that with respect to our xy system, or with respect to our xy coordinate frame, if a vector drawn from the origin makes an angle theta with the positive x-axis and has a magnitude of certain amount that we know, then by dropping a perpendicular on the x-axis like this over here and calculating effectively this x coordinate, this one, we can calculate what is called the x component of the vector. So this becomes ex I cap, where I cap is a unit vector along the x-axis, and similarly by dropping a perpendicular on the y-axis, effectively finding out the y coordinate, we can now express what is called the y component of the vector. Ej cap, and ultimately we can see that the vector E, when we write it in component notation, can be written like this: ex I cap plus ey j cap. This is the vector in what we call component form. It's written as an equation in component form. और यहाँ पे vector geometrical form में, because we have drawn the vector. In component form, you understand that Ax and Ay are the x component and the y component respectively. And they are basically, this Ax and Ay are scalars, whereas I cap and j cap are the special vectors which are called the unit vectors. This is the unit vector, that means the vector of magnitude unity or 1 along x-axis. And likewise j cap is the unit vector along y-axis. Okay, so this was the relationship between the two. A vector which is drawn like this will be written in component form in this way. Now what is the conversion between geometrical and component form or vice versa? So if we know the magnitude, given the magnitude of the vector E is a known quantity and the angle theta with respect to positive x-axis, then we can find out these like this. So this is a conversion from geometrical form to component form. Whereas, so if this is geometrical form is known, so this is now converted to component form. Where similarly, if Ax and Ay are known to us, okay, and we want to express it in geometrical form, or we want to find the magnitude. So the magnitude of the vector becomes root of Ax square plus Ay square, and theta becomes tan inverse of Ay by Ax. So this is given in component form, converted to magnitude and angle. That's how we convert this to the magnitude of the vector and the angle it is making with the x-axis. Okay. So this is what we had looked at in the last lecture. And we will discuss a little bit more about this angle in 4 quadrants and all that later today. Okay. But now with this information, let us come back to the worksheet number 3 and discuss some of the questions. Okay. So does anybody have, we need to discuss anything between question 1 and 4? Question 1 to 4, does anybody have doubts? Please drop me a message if there are any doubts between question 1 and 4. No, it's all right. No doubts. Okay. What about question number 5? Okay, so let's start with question number 5. Okay, Mayank, I will solve question number 1. Don't worry. Right, so we have a couple of students who have doubts in question number 1. Let's start with that. So, worksheet or assignment 3. Start with question number 1. So in question 1, what is happening is that 2 vectors are given to us in component form and we have to find the magnitude of their sum. So the vector E is given to us as 2i cap plus 2j cap, and the vector B is given to us as I cap plus 2j cap. This information is given, and now we want to find the magnitude of E plus B. Okay. So first we will find A plus B. So first find E plus B will be equal to this vector, that is 2i cap plus 2j cap plus I cap plus 2j cap. So now just open the brackets and take I cap common. So we have 2 plus 1 I cap plus 2 plus 2 j cap. So that becomes 3 I cap plus 4 j cap. Okay, so this is what our vector A plus B becomes. So therefore, the magnitude of this vector A plus B is nothing but magnitude of 3i cap plus 4j cap, which is defined by that formula, root of x component square plus y component square. So that is becoming 5. So magnitude of A plus B is becoming 5. All right. So this is the way of doing it. Hope you understood it, Mike. Okay. So the simple concept that we use here, if we look at this question conceptually, what we are saying is that if a vector A has components Ax and Ay, okay, and a vector B has components Bx and By, okay, then the sum of the vectors will simply become the sum of the x components plus the sum of the y components. Okay. This is the concept that we are using in this question. All right. So hope this is clear. All right, Ansh, we will come to the third question after this. Just make sure you have noted down this question and understood the concept of this first. Mayank, why you can't solve by triangle law is because see, triangle law से अगर आपको solve करना है, आपको magnitude of A चाहिए, magnitude of B चाहिए, but theta भी तो चाहिए ना. So in the first question, from this you can find out that okay, magnitude of A is 2 root 2. That you can find out. Magnitude of B is root 5. Okay, but theta ये क्या होगा? That I don't know. So I cannot apply triangle law. Sarthak, this under root का concept is here. We have just discussed this over here. The magnitude of any vector is given like this, ना? तो कोई सा भी मेरे पास vector हो जिसका x component, okay, I have any vector, let's say this, which has some x component and some y component. What is the magnitude of that vector? It is root of x square plus y square. So over here I have a vector p plus b, which is 3i cap plus 3j 4j cap. So 3i cap plus 4j cap का magnitude कितना हो जाएगा? इतना हो जाएगा. No, but that theta is the angle that the E is making with the x-axis. No? But what about the angle between A and B? You understanding me? So we can find out, but it will be very complicated. कैसे निकालें? देखो, if you want to do it that way, you have to first understand this, na, that the vector A and B, what they are looking like in the xy plane. Okay. So the vector A will be something like this. It's 3i cap, sorry, it's 4i cap plus 4j cap, was it? Or 2i cap plus 2j cap, anyway. So it will be like this. Suppose this is our vector E. Two I cap plus 2j cap. Now we can see from this that, okay, magnitude of E is 2 root 2. And also the angle is tan inverse 1. So that is 45 degrees. So that's fine. So this angle is 45 degrees. Okay. And this magnitude is 2 root 2. So A के लिए तो मैं पता है. Okay, this is the situation. But similarly, we have to draw for B also. No? Now for B, life is a little more complicated. Okay. For B, what is happening is that the vector is, what was it now? I cap plus 2j cap. So that vector will look something like this. इसका y component same होगा, but x component इसका half होगा. So B is some vector like this, let's say. So for the vector B, which is I cap plus 2j cap, you can see that the magnitude of the vector B is root 5. But what about this angle? Now this angle is, let's say, some beta. Okay. So beta is how much? It is tan inverse 2. Okay. And let us say this angle which we have written 45, I am labeling this as, suppose, alpha. इस वाले एंगल को मैं भी अल्फा लिख रहा हूँ. So alpha is equal to 45 degrees. Okay. This is alpha. Now to apply triangle law, if you want to apply triangle law here, you have to find out theta, because magnitude of A plus B will be root of A square plus B square plus 2AB cos theta. इसमें mod A मुझे पता है 2 root 2 है, mod B मुझे पता है root 5 है, but what about theta? Okay, so in the diagram you can see theta is this angle. Theta is the angle between the vector A and B, this one. So theta will become alpha minus beta. Now that will become hugely problematic here, because this is okay, this is 45 degrees, but this one is not an angle we know. No? We have to find it out first, then from that we have to find cos theta. So it becomes a very, very unnecessarily lengthy question. So we don't do it this way. Okay. So this is by triangle law. Okay. And because this becomes so lengthy, we'll avoid this method. We'll simply calculate it by component method. So next, by component method. So E plus B का mod just becomes first calculate E plus B. So E was 2 I cap plus 2 J cap plus B was I cap plus 2 J cap. पहले ये वेक्टर निकाल लो फिर इसका mod निकालो. 3 I cap plus 4 J cap. So that becomes, yeah, it's not one of the regular angles tan inverse 2, but you can work it out from, you can use a scientific calculator to find out tan inverse 2. Okay, so I'm using one and telling you right now. Tan inverse 2 is about 63.4 degrees. Tan inverse 2 becomes about 63.4 degrees. So this beta minus alpha. That beta, which is tan inverse 2, is approximately 63.4 degrees. And alpha was tan inverse 1, which is 45 degrees. Okay. So this difference will become like that. हाँ होता है ना tan, because you see what is happening, tan 90 is tending to infinity ना. आपने tan का ग्राफ देखा है ना, sin and cos only happens from 0 to 1, okay, but tan happens up to infinity. The graph of, in trigonometry you must have seen, no? The graph of tan x like this, no? It goes like this. So it covers, goes to infinity. Yeah, exactly. Sin and cos are limited. Sin and cos graphs are limited between 0 and 90, for example. They are limited between 0 and 1. This is your sin x graph. But your tan goes to infinity. That you know from the values, ना? ये तो आपको trigonometry में पता है बेटा. Okay. Anyway, so let's come to question number 3 now. नहीं, cot infinite values नहीं होता है. Cot is 1 upon. Okay. So cot is between 1 and infinity. Okay, these are things in trigonometry, beta. You should know these from trigonometry. You look up any standard book or reference material in trigonometry, you will get your values in all these things. आपके मैथ्स के बुकलेट ऑफ ट्रिग्नोमेट्री में भी आपको ये सब इंफॉर्मेशन मिलेगा. कॉट का ग्राफ कैसे होता है, साइन का ग्राफ कैसे होता है. ओके, सेकंड क्वेश्चन आल्सो फाइन. लेट्स कम टू दैट. सो ए प्लस बी का एंगल निकालना था विद रिस्पेक्ट टू एक्स एक्सिस. सो क्वेश्चन 2 wanted to find the angle of a plus b from question 1 with respect to x-axis. It is very simple, ना? E plus b हमने अभी देखा क्या था? It was 3 I cap plus 4 J cap. So the angle is making with the x-axis is tan inverse 4 by 3. Sorry, it was 4 I cap plus 3 J cap. क्या था? 3 I cap plus 4 J cap. Okay, this one. And that is nothing but 53 degrees. By definition, you know ये 53 होता है. Okay, we had discussed about this. This angle is 53 when your right angle triangle is like this. Okay, is it clear, Mayank and Sarah? Okay. Next, let's come to question number 3. So 3 may you have to find the component form of this given vector. Okay. So the vector is drawn arbitrarily like this. Drawn something like this. Its magnitude is 10 and this angle is 30 degrees. Now to find the components, we'll have to redraw the vector from the origin. Okay. So what you do is you take this vector only, but you shift it to the origin. It's the same vector. This angle is 30. So the angle it is making with the positive x-axis is 120 degrees. So now you can understand the components in two ways. One is in the diagram. You can see that ये component और ये component कितना हो जाएगा? This will be minus 5 root 3 and this will be plus 5. So you can see that yes, it is necessary because otherwise you can't understand the proper quadrant of it. Or another way to understand it is by formula. Sorry, this angle will be 150 by mistake. Just make a correction here. ये 30 है ना, so ये angle 150 होगा. So by formula method now this is 150. And this is okay, so that's your x component, that's your y component. So two different methods by which you can do this. One is trigonometrically in that triangle you can work out the hypotenuse 10 है, ये वाला angle 30 है. So this is 5 root 3 but it's along the negative side and this is 5 but it's along the positive side. So with sign the components are becoming like this. The other is you can directly see that if this angle is 30 then the angle theta with respect to the positive x-axis is how much? 150. So you use trigonometry formula. Yes, we in projectile motion you use the components to find out the horizontal. I mean, you use the angle to find out the horizontal and vertical components of velocity. That's correct. In projectile motion, that happens. All right, that's question number 3. What about question 4? Anyone has a doubt in it? Question clear है बेटा सबको? Okay, let's come to question 5 then. Okay, so in question 5, the sum of 3 forces is 0. Then we have to find the third one of the 4. Okay, right, of the 3 rather. So forces F1 and F2 are given to us. F3 is the unknown force, but it is given to us that F1 plus F2 plus F3 is equal to 0. From this, we have to find the magnitude of this force. Okay. So I'll just give you a hint on how to solve this. Since F1 plus F2 plus F3 is equal to 0, we can say that F3 is minus of F1 plus F2. Correct? This statement is clear. So now all you have to do is you have to substitute these here. Substitute these two values here. And from this you'll be able to find out F3. Okay. And from that you'll be able to find out magnitude of F3. Try out this question by this method now. Oh, my mistake. This is एक minute guys, I made a mistake in copying the question. This value is given as 13. Okay. This value is given as 13. I'm seeing some other question. Yes, F2 is minus 8 and 13. Because they are unit vectors. This all I have discussed in the last lecture ना, आपको बताया है कि कैप नोटेशन किसके लिए यूज करते हैं, स्टैंडर्ड यूनिट वेक्टर्स के लिए यूज करते हैं, और एरो नोटेशन किसके लिए यूज करते हैं, कोई भी वेक्टर के लिए. आप लेक्चर नोट्स तो रिवाइज किया कीजिए कम से कम. So getting the question, people. So now you substitute here ना. So vector F3 is equal to minus of f1. f1 कितना है 12 I cap minus 16 j cap plus f2 और f2 कितना है minus 8 I cap plus 13 j cap. So next step, you take I cap and j cap common inside this bracket. So you have 12 plus of minus 8. So there's 12 minus 8 I cap and minus 16 plus 13 j cap. So this is becoming 4 I cap minus 3 j cap, and then finally take the minus sign inside. So minus 4 I cap plus 3 j cap. This is your vector f3. Okay, so now you have to find the magnitude of f3. So just apply the formula. That is how much? 5. Is this clear, people? Understood the question? Yes, Sarthak, 5 is the correct answer. Fourth question also. Okay, let's understand the fourth question. So question 4. Vector E is given to us as 12 I cap plus 16 j cap, and vector V is given to us as minus 8 I cap plus 6 j cap. Now we want to find the angle theta between them. Now one of the things is we can do is we can use the formula magnitude of A plus B is magnitude of A square plus magnitude of B square plus 2AB cos theta. Now in this we can see that magnitude of A is how much? It is root of 12 square plus 16 square. So that is 20. Hope you all know this. Magnitude of B is 10. And E plus B. First to calculate how much is A plus B from here. It is 12 minus 8 plus 16 plus 6. So that's 4 I cap plus 22 j cap. magnitude of a plus b. So that you can calculate. Now substitute them over. Converse of Pythagoras. But how you use Pythagoras theorem? Yeah. Okay. So now substitute that over here. So root 500 is equal to e square. So that's 20 square plus b square. Now square both sides. So 500 is equal to 400 plus 100 plus 400 cos theta. So this is showing you that cos theta is 0, which means that theta is equal to 90 degrees. Okay, good. Udit and Varun, you have spotted the question correctly. Anyone has done this question by some other method? This is to find theta. But you can also do this question geometrically. Try this now. After finishing this, try this. Okay. Draw the vectors A and B in the xy plane. Okay. And from that, find the angle theta. Try it by this method. The vectors A and B are given to you in I cap, J cap notation. Now draw them in the xy plane. And that's another method by which you can show that they are perpendicular. The angle between them is 90. You're understanding what I'm saying, people? This is not the only method by which you can do. In fact, this is a lengthy method of doing this question. You can also do it by this. You can geometrically draw the two vectors A and B. And from the diagram, you can figure out the angle between them. Try working it out by geometry, all of you. Finish writing down this method first and then try it by the second method I have written below. Done. Okay, very good. Okay, so let us see this by the geometrical method for everybody else also. So vector E is 12 I cap plus 16 j cap. That means when I draw the vector E will be something like this. It's of magnitude 20, and this angle it is making is 53 degrees, okay, because theta that is makes tan inverse 16 by 12 or tan inverse 4 by 3. Okay. So that is a vector E. Now similarly, what about the vector B? Now B के लिए जो क्या है? It is minus 8 I cap plus 6 j cap. Okay. So you can see that B is a vector which has a negative x component and a positive y component. So the vector has to lie somewhere here. This vector B. So this one you can see that the magnitude of B is 10. But what about this angle it is making? यहाँ पे अभी ये कितना है? ये -8 है और ये कितना है? 6 है. So if this angle is some alpha, you can see that tan alpha is 3 by 4. So alpha is equal to 37 degrees. Okay. So that means this angle it is making, the angle with the x-axis for that vector, वो कितना हो जा रहा है? It is 180 minus 37. So 143 degrees. So यहाँ पे ये angle कितना है? 143 degrees. So therefore you can see that the angle between A and B will become 90 degrees. This will become 143 minus 53 or 90 degrees. Very good. So this is another way in which you can show that the vectors are perpendicular to each other. Okay, 6th and 7th, anybody has a doubt? Question 6 and 7? Okay, then let us move on to 8th question then. 8th question is quite complicated. It's the difficult question in this exercise. 8, 9, 10, that series of problems actually. So now pay a lot of attention, okay, because this is a slightly more tricky type of question. Question 8 and the related question 9 and 10. So first of all, there's a whole lot of information जो दिया हुआ है. We have to interpret that information correctly. Okay. In question 8, it is given to us that magnitude of the vector E is 5. That is the first thing given. Then it is given to us that C is a vector given by A plus 2B. Okay. And it is such that C is perpendicular to E. That's one more information given to us, that C is at 90 degrees to E, and also given to us that another vector D is equal to E plus B, and the information about D given is that the magnitude of D is equal to 5. So these three types of information are given to us. Okay, and from this we have to find out the magnitude of B, okay, the angle theta between A and B, the magnitude of the vector C also. I think so many different things we have to calculate. Magnitude of C, that's question 8 itself. Then that's question 9, magnitude of B, and the angle between A and B. So 9, 10, these two other questions we have to find out. So इसको हम कैसे करेंगे? Let's understand. ठीक है. So see, given to us these two informations, okay, this one and this one, they correspond to two triangles. So draw vector triangles for operation 1 and operation 2. So operation 1 में क्या हो रहा है? We are given that the vector C is equal to A plus 2B. Okay, where C is perpendicular to E. So let's see what kind of triangle that gives us. So if this is some vector E, and remember E का magnitude 5 दिया हुआ है, then C should be a vector perpendicular to this. We don't know how much its magnitude is, but we know that it's perpendicular. So it's something like this. Okay. It's at 90 degrees. So C is coming by adding A with which vector? With 2B. So 2B, that is 2 times the vector B, should be here. That's how it is. So 2B should be like this. So the magnitude of this side is 2B. Suppose the angle between A and B was some theta, then the angle between A and 2B will also be theta. Okay. That's the important thing here, that if theta is the angle between A and B, then the vector 2B will also be at theta with respect to E. Vector triangle. I'm just using the concept of vector triangle. अगर ये मेरा वेक्टर A है और ये मेरा वेक्टर B है, then this vector becomes A plus B. So like this, if now this is my vector E, 2B is a vector like this now. It's just of magnitude 2B. This is of magnitude B. So it's B plus B. But whatever this angle was, यहाँ पे ये angle भी तो same रहेगा ना. And A plus 2B will become this vector now. Become something like this. But in this particular case, this angle, this one, this has to be 90 degrees. So the triangle has to be like I've drawn above. It has to be of this type. So that's the idea. Understood? So this is a concept we are using. So this line here is very critical, which I've written. This one. Here, अगर A and B के बीच angle theta है, then 2B will also be at theta. Why? Because 2B is along B only. No? It is along the vector B. That's why. Now, in comparison to this, if I draw the vector triangle for the second operation, second operation was B is equal to A plus B, and in this it was understood that magnitude of D was equal to magnitude of E, which is 5. So this particular triangle will become like this. From that triangle, I'll borrow B, which is half of that. So this is the vector B. इसका magnitude मुझे नहीं पता, but उसका आधा है. This angle theta is the same as that one, and this is vector E. This is magnitude is 5. So now this should be the vector D, which is the sum of A and B, and this one's magnitude is also 5. So these are the two triangles that I'm getting. Now in the two triangles, what all are unknown to me? The two triangles, B's magnitude is unknown, theta is unknown. Okay. So I need equations to solve them. Okay. C is also unknown. C's magnitude is also unknown, but D's magnitude is known, A's magnitude is known. Okay. So from the first triangle, I can use Pythagoras theorem. So from operation 1, from the first triangle, use Pythagoras theorem. So 2b ka whole square will become c square plus 5 square. Or 4b square is equal to c square plus 25. Okay. This is the first thing that we are making use of. Triangle 1. Okay. The other thing is, in this triangle you can see that if this angle is theta, then what about this angle? It is 180 minus theta. So cos of 180 minus theta is how much? Base upon hypotenuse. So cos of 180 minus theta will be the base, which was 5, upon the hypotenuse, which was 2. That's my second equation. Now cos 180 minus theta can be written as minus cos theta. So minus cos theta is 5 by 2b, or cos theta should be minus 5 by 2. In fact, let's write these two equations as 1 and 2. This is what we are going to use. So this is equation 1. This is equation 2. So मेरे पास 3 unknowns थे, theta, b and c. 2 equations मुझे यहाँ से मिल गए. अभी तीसरा equation मैं कहाँ से generate करूँगा? इससे generate करूँगा. Okay. So from triangle 2, okay, now use triangle law. Okay. So magnitude of a plus b, in this case that is b, is root of a square plus b square plus 2ab cos theta. So this is now telling me what, that 5 is equal to square root of 5 square plus b square plus 2 into 5 into cos theta. Or we can square both the sides. Okay. So squaring both the sides, we get 25 is equal to 25 plus b square plus 10b. This is ab, so there will be another b over here. 2 into a, which was 5, into b into cos theta. Okay. So plus 10b cos theta. So square of the left hand side is equal to square of the right hand side. So finally this is giving me the equation that b square plus 10b cos theta is equal to 0. Or I can take b common outside, and b plus 10 cos theta should be equal to 0. So this is my third equation. Now we will solve the 3 equations together and we'll get the values of the unknowns. So solve equation 1, 2 and 3 to find D is C and theta. So first of all, let's understand the method. Because they are vectors, na beta. Vectors don't add in the same way like scalars add. That is the whole point of vector algebra ना. हमने पहला दिन ही देखा था कि vectors का addition direction के हिसाब से होता है. Scalars ऐसा नहीं होता है. थर्ड इक्वेशन में b लिखा नहीं. b लिखा है. Here I've taken b common. No? So from this, okay. So now b can't be 0, so it must be this bracket which is 0. So first understand how these two operations, c is equal to a plus 2b and d is equal to a plus b, are converted into these two triangles. This is a right angle triangle. Why? Because it's given to us कि c इसके perpendicular है. Good Kanishk. Okay, now let us see how we'll solve the equation. So what we do is from equation 2, substitute cos theta in equation 3. Very simple equation solution. So इसको यहाँ पे substitute करो. So on substituting this, you will get b plus 10 cos theta, where cos theta is minus 5 by 2b is equal to 0, or b minus 50 by 2b is equal to 0, or that 2b square is 50, or b square is 25. It will tell you that b is plus minus 5, but here we'll take only plus 5 because b is magnitude of vector b. It cannot be a negative quantity. Okay. So since b is mod of vector b, it is 5. It cannot be minus 5. Okay. And cos theta will become minus half, which means that theta is 120 degrees. And c will become, from equation 1, you can see that c is square root of 4b square minus 25, or square root of 75 हो जाएगा ये. So c will become 5 root. So these are your 3 answers for questions 8, 9 and 10. Yes, very good. Varun, that's correct. Ganesh, you have also got this. Okay, so next up for question 11, 12, 13, 14, you have the same figure. They are linked questions. They are based on the same information given in that diagram. Let's look at that. So in question 11 to 14, you have to check various options for sum and difference and those kind of things of vectors A, B and C, where A, B and C are given to you in the diagram. So best way to do the question is from the diagram, convert them to component form. So then you can check the operations very easily. So in the diagram, you can see that the vectors A, B and C are given like this. E is a vector of magnitude 10 at an angle of 60 degrees. B is a vector again of magnitude 10, but an angle making 120 degrees with the x-axis, because the angle with the negative x-axis, this one is 60, which means that this angle is 120 degrees. So that's the vector B. It's magnitude 10. And similarly, we have a third vector C, which is along the x-axis. And its magnitude is 10. So what you do from this is, now for example, you want to check out things like this. in question 11, for example, the options you have to check out is E plus B, then E minus B, etc. You have to find out these things. So what we do is write all the three vectors A, B, and C in component form first. This is the first thing you do. And then what you do is calculate E plus B and A minus B, but again in component form. And from that you will be able to check the options. Then you can check the options with everything. So just write vectors A and B in component form first. That should be very easy. We've just been discussing these things. तो इनको आप component form में लिखते हैं ना. C you can see is very easy. C is 10 I cap. So like that only A क्या होना चाहिए, B क्या होना चाहिए. Write them in component form. Okay, Ganesh, I will check the options. Okay, question 11, I'll check the answer. No, C is not correct. D correct answer. I'll tell you how. We'll work it out. I'll tell you how. Yes, it should be B. Okay. So कैसे होगा देखो, for the vector A, magnitude is 10 and your this thing angle with the x-axis is 60 degrees. So what is the x component? 10 cos 60. So that is 5. Sorry. And what is the y component? 10 sin 60. So that is 5 root 3. So vector A क्या होना चाहिए? 5 I cap plus 5 root 3 j cap. Similarly, for the vector B, the magnitude is 10, but the angle with the x-axis is how much? 120 degrees. No? So what is the x component? ये कितना होना चाहिए? It should be 10 cos 120. Now cos 120 is minus half. So minus 5 होना चाहिए. And sin 120 is how much? Sin 60 or plus root 3 by 2. So this should be 5 root 3. So this should be minus 5 I cap plus 5 root 3. Okay. Now once you got these, you see now what is A plus B? E plus B is becoming minus 5 plus 5 root 3 plus 5 root 3 j cap. Or E plus B. ये वाला component 0 है, so it is just these two, so that is 10 root 3 j cap. So what we can say about the vector A plus B? E plus B is along the y-axis and has a magnitude of 10. So this is what we can say about E plus B. Similarly, E minus B क्या हो जाएगा? E minus B will be this vector E, it's 5 cap plus 5 root 3 j cap minus of this whole vector B, which is minus 5 I cap plus 5 root 3 j cap. So that will become 5 plus 5 I cap plus 5 root 3 minus 5 root 3 j cap. So this is becoming 10 I cap plus 0 j. So that means vector E minus vector B is along the x-axis and has a magnitude 10. अच्छा, incorrect option निकालना है. Okay, let me check. Sorry, I have not. Which option is incorrect? E plus B points along the y-axis. That's correct. E plus B has a magnitude 10 root 3. That's correct. E minus B points along the y-axis. That's wrong. And E minus B is of magnitude 10. That's again correct. So yes, you should select the incorrect option will be C. Just make a correction in the answer key if it is given as B. The incorrect option will be C for question number 11. Okay. Just make a correction in the answer key. If it's given as B, then just make it C. Sorry, I did not see that it's incorrect option. Yeah. So incorrect option is the C one. बाकी तीनों ऑप्शन करेक्ट है. So now move on to question number 12 from this. So in 12 we have to check E plus B plus C. For question number 12, you have to find out the magnitude of A plus B plus C. So पहले आप A plus B plus C as a vector निकाल लो I cap J cap form में, the component form में. So it is 5 I cap plus 5 root 3 J cap plus B is minus 5 I cap plus 5 root 3 J cap plus C is 10 I cap. So now take I cap common. So we have 5 minus 5 plus 10 I cap and take J cap common. So we have 5 root 3 plus 5 root 3 J cap. C doesn't have a J cap component. So it's 10 I cap plus 10 root 3 J cap. This is becoming E plus B plus C in component form. So therefore its magnitude is magnitude of 10 I cap plus 10 root 3 J cap. So that is square root of 10 square plus 10 root 3 ka whole square, from which if you take 10 common, okay, so that's becoming 20. So that is your magnitude of E plus B plus C. नहीं बेटा, angle between A and B is it is 60. नहीं, incorrect option है बेटा वो. Option C is the incorrect option. Magnitude of A plus B is not 10, it is 10 root 3. Magnitude of A minus B is 10. E plus B का magnitude 10 root 3 बेटा, so it doesn't form an equilateral triangle. Okay, people, so hope this is clear so far. Okay, likewise in question 13, you have to find out which of these is a null vector. मतलब उनका sum 0 होना चाहिए. So there you have to actually check out each one. So in question 13, you have to check out each of the options. Given that you know the vector E is 5 I cap plus 5 root 3 j cap. The vector B was minus 5 I cap plus 5 root 3 j cap, and the vector C was 10 I cap. Okay. So now you can see that option A, you are having E minus B plus C. So पहले निकाल लो E minus B plus C कितना होगा. So E minus B plus C will become 5 plus 5 plus 10 I cap plus 5 root 3 minus 5 root 3 j cap. So that's actually becoming 20 I cap. So definitely that's not 0. That option is not correct. Then similarly, you look at the next option, B minus A plus C. नहीं होता है ना, because its magnitude is 0. Null vector doesn't have any direction because its magnitude is 0. So B minus A plus C कितना है? It is minus 5 plus 10 I cap plus of 5 root 3 minus 5 root 3 j cap. So it's 0 I cap plus 0 j cap. So that's nothing but a null vector. So that's the correct one. So this is the correct option. Similarly, you can work out C and see that it will not be correct. You calculate E plus B minus C. C won't be correct because this will give you, again, E plus B is 0 plus C 10. So this will give you 10 I cap. Okay, so that's not 0. Sorry, 10 I cap plus 10 root 3 j cap. No, E plus B minus C. So ये वाला 0 हो जाएगा. Okay, 0 I cap, but plus 10 root 3 j cap. So again, this is not 0. So that's why this option is wrong. Okay, so that's question 13. Hope you understood this. So V is it clear? Null vector doesn't have any direction. उसका कोई direction नहीं होता है because उसका magnitude 0 है. It's basically an arrow which does not have any length. So it's basically nothing. Null vector is basically 0. It's nullity. Alright, similarly question 14 you can work out. E plus B plus C हमने पहले निकाला क्या? For question 14 we had seen earlier that E plus B plus C was actually how much? It was we calculated this now. Yeah, this part. So it was how much? 10 I cap plus 10 root 3 j cap. We worked this out already. It's 10 I cap plus 10 root 3 j cap. So it is at theta equal to tan inverse of y by x, so that is root 3 or 60 degrees with respect to x-axis. Okay, and question 15 is very easy. You have to just put the magnitude of that vector as 0, so I'm sure all of you can work it out. So this completes the discussion of the worksheet number 3. Now we'll move ahead and understand some more aspects about vector algebra, both components and geometrical method. Just make sure that you got these questions worked out. With the x-axis, we always assume that they are specified about the positive x-axis. Okay, the common meaning of x-axis like that is always that we are talking about the positive x-axis. We'll make that assumption over here. All right, is it clear? Okay. Now, few more things I want to discuss about components and vectors. So next we'll understand component form of vectors in 2 dimensions and this thing, the ESTC rule in trigonometry. How we understand these things. Okay. So second quadrant के जो ESTC formulae होते हैं, how we can derive that using vector algebra. Quadrant 2. So if a vector is in second quadrant like this, such that this angle is theta, okay, then its x component is a negative quantity. And its y component is a positive quantity. So ये जो x component है negative है, ये जो y component है ये positive है. Okay. But if you look at this right angle triangle, यहाँ पे ये 180 minus theta है, this angle. Okay. So I'm just saying, look at this right angle triangle, this one. इसमें क्या हो रहा है that cos of this angle, cos of 180 minus theta should be equal to the base. Now base कितना हो जाएगा? Mod of ax, because ax is a negative quantity. So the length of the base will be how much? Mod of ax. Upon the magnitude of the vector. So that is telling me that ax or mod of ax is how much? E cos of 180 minus theta. Now since ax is negative, therefore we can say ax itself is negative of its mod. Okay. Whenever a quantity is negative, it's minus time its magnitude. So that means ax is minus of e cos 180 minus theta. Okay. Now what is the definition of the x component of a vector? The definition of x and y components is that the x component is magnitude times cos theta, and the y component is magnitude times sine theta. So substitute that over here. So Ex should be equal to how much? E cos theta, and that is how much? Minus E cos of 180 minus theta. So this is coming from equation 1. Okay. So therefore you are seeing that cos theta becomes minus of cos 180 minus theta. This becomes one important formula for your second quadrant. Quadrant 2, or when theta is between 90 degrees and 180 degrees. जो आपने ट्रिगोमेट्री में सीखा ये फॉर्मूला, उसका वेक्टर अलजेब्रा से डेरिवेशन ऐसे होता है. Similarly, in that triangle, sine of that angle, sine of 180 minus theta is perpendicular upon hypotenuse. Now the perpendicular is the length of that side. So the length of this side here, you can see it is EY only. This side is the same as this. Okay. So from this we are getting mod of EY is E sine 180 minus theta. Now since EY is positive, therefore we can say EY is positive of mod EY. So that means E sine theta is positive of E sine 180 minus theta. So we have the formula that sine theta is sine of 180 minus theta in the second quadrant, when theta is between 90 and 180. Now this same method of logic we'll use for the third and fourth quadrant also, and that's how we'll understand that in third quadrant tan is positive, sine and cos are both negative, and in fourth quadrant cos is positive and sine and tan are negative. So just make a note as this. So make a note of the heading also, just to get the heading down. I have written above component form of vectors and ESTC method for trigonometry, the relationship between the two. That is the subtopic. So this is the part for quadrant 2. finished writing this down, people? Okay. Okay, done now. Okay, so finished, I hope. Now, similarly, let us look at the next quadrant. So, quadrant 3 formula. So, if our vector is making an angle which is greater than 180 but less than 270 degrees with the x-axis, then it will lie in the third quadrant. Okay, so physically, this is that situation. This is that case. Okay. So, in the third quadrant, theta is more than 180 degrees, less than equal to 270 degrees. So, in this case, you can see both the x and y components are negative. X component भी negative होगा, y component भी negative होगा. They're both negative. Okay. Now, if this angle, we take it this as alpha. So we can write theta as 180 plus alpha, or we can write alpha as theta minus 180 degrees, like this. So now pick up this triangle which I am showing here. ये वाले right angle triangle को suppose we draw it separately. So you can see that right angle triangle like this. This is the magnitude of the vector A. This angle is our alpha. This side is as a side length, it is mod of Ax. This side as a side length is mod of Ey. So again, we are having the trigonometric relationships that cos alpha is equal to mod of Ax divided by E. Or that means magnitude of Ax is equal to E cos alpha. Or that is the same thing as E cos theta minus 180 degrees. Okay. Now, Ax is a negative quantity. So therefore, Ax will be written as negative of its magnitude. So Ax will become minus of E cos theta minus 180 degrees. And by definition, Ax is nothing but E cos theta. So we have cos theta as minus of cos 180 theta minus 180. This becomes the formula for cos theta in quadrant 3. So for example, cos of 225 degrees becomes minus of cos 225 minus 180, or minus of cos 45, or minus 1 by. Okay, so this is an example of this formula. Okay, just note this down, people. And similarly, work out the formula for sine theta yourself from here. Similarly, you should be getting sine is also negative in this third quadrant. So similarly, you can see in this that your sine alpha will become mod of Ey by E. So that means mod of Ey is E sine alpha or E sine theta minus 180. But now here Ey is also negative. So Ey will be negative of its mod. So Ey will become negative of E sine theta minus 1, or E sine theta will be negative of E sine theta minus 180. So sine theta will be negative of sine theta minus 1. ये दोनों मिला के they are the third quadrant form. So both sine and cos are negative. Tan becomes positive. So this is something you know very well from trigonometry, PSCC, but this is how you can justify it by vector algebra also. Alright people, so following this, and similarly the quadrant 4 formulae, I'll just write down the formula, you can try the derivation yourself. For fourth quadrant, theta being greater than 270 degrees but less than 360 degrees, less than equal to 360, we have the formula that sine of theta is minus sine 360 minus theta, and cos of theta is positive of cos 360 minus theta. And just division of the two will give you the relation that tan theta is minus tan 360 minus theta. So you have the formula, for example, that sine of 315 degrees, ये कितना हो जाएगा? This will be minus sine 45 degrees or minus 1 by root 2. Okay. Or cos of 300 degrees will become positive of cos 60, so that is half. Okay. Or tan of 330 degrees will be minus tan 30 degrees or minus 1 by root. These are all examples. So again, these formulae you can justify by making a vector diagram and relating the components like we've done earlier. Make a vector diagram and relate the components. Realize you have something like this. So if your vector is lying in the fourth quadrant, uska anti-clockwise angle with the x-axis is like this. And this is your theta. You can use the same methods that we discussed earlier. Drop this perpendicular, drop this perpendicular. You can see that if this angle is alpha, now the x component is positive, whereas the y component is negative. You can use that same kind of method that we discussed earlier. Ax will be mod of ax, which will be e cos alpha. Ey will be minus of mod ay, which will become minus a sin alpha. From that, you will get these formulas. Alright people, so this is clear. Hope you understood this. So this is another aspect of the relationship between trigonometry and vectors and component algebra in 2 dimensions. Okay. So with this you complete component algebra in 2 dimensions and we come to the last part of components, which is now components of a vector in 3-dimensional system. So 3-dimensional system से क्या मतलब है? It is what we call Cartesian coordinate frame that consists of 3 axes, x, y, z axis, which are mutually perpendicular. So now this is where again you have to pay attention. This is a diagram that we are drawing, which you should understand as 3-dimensional. तो इस diagram को interpret करने का सबसे अच्छा तरीका क्या है? Just think of this as the corner of the room that you are sitting in. आप जिस रूम में बैठे हैं, आपके सामने जो wall है, उसके जो bottom left side में जो corner है, वो आपका origin है. So the edge between the 2 walls, एक wall आपके left side में, एक wall आपके सामने है, उनके बीच में जो edge है, जो vertically ऐसा जा रहा है, that edge is your y-axis. Floor और front wall के बीच जो edge है, वो आपका x-axis है, and left वाले wall और floor के बीच में जो आपका edge है, that is your z-axis. So these are 3 mutually perpendicular axes, such that आपका जो xz plane है, that is the floor on which you are sitting. This is like the floor of the room on which you are sitting. xz plane is like the floor on which you are sitting. जो yz plane है, वो आपके साइड में जो वॉल है, वो वाला है. आपके लेफ्ट हैंड साइड में जो दीवार है और the wall that is present, that is your yz plane. This is your wall to your left, and the wall which is in front of you, the one which you are facing straight, that is your xy plane. The one which is facing in front of you, that is okay. So you can see that they are mutually perpendicular. Mutually perpendicular axes and planes. So that means x-axis is perpendicular to y-axis. Y-axis is perpendicular to z-axis. And on the floor, x-axis is perpendicular to z-axis. So x is perpendicular to y-axis. Y is perpendicular to x-axis. To z-axis. And z is also perpendicular to x. They are mutually perpendicular axes. So it's a system of mutually perpendicular axes. And this is the best way to visualize it. So in this kind of system, when we write the vectors in component form, it is called 3-dimensional component system. So another way to visualize the three-dimensional component system a three-dimensional coordinate frame, coordinate system, is that just imagine you have a rectangular box, a cuboidal kind of box. So imagine we have not a perfect diagram, but it will do for now. So this is a cuboid, okay, or a rectangular box. So any one corner of that you imagine is your origin, and correspondingly these edges become your XYZ axis. इस डायरेक्शन को हम अपना x एक्सिस ले लेंगे, इस डायरेक्शन को हम अपना y एक्सिस ले लेंगे, and इस डायरेक्शन को अपना z एक्सिस. So they are three mutually perpendicular axes. You can see that mutually perpendicular axis, x, y, and z axis. So there is another way to visualize the three-dimensional coordinate system where x, y, z axis are three mutually perpendicular directions or three mutually perpendicular axes. Now in this system, once we have developed the coordinate frame, a vector in component form is written like this. It is written as Ex I cap plus Ey j cap plus Ez k cap, where the new thing is k cap, that is a unit vector along z axis, along the positive z axis. I cap and j cap are the same as they were before. They are unit vectors along x axis and unit vector along y axis. But the new one in addition is this. And similarly, Ez is what we call the z component of the vector along with y. Okay, so hope this is clear, people. Just make a note of this. So this is components in three-dimensional system. This is how we write a vector in component form when it is expressed in three-dimensional system instead of two-dimensional system. Okay, people, hope this is clear. And just like in 2D, you had the magnitude of a vector as root of ax square plus ay square. In 3 dimensions, the magnitude of the vector becomes root of ax square plus ay square plus az square. Okay. So therefore, for example, suppose I have a vector E, which is 3 I cap plus 12 j cap plus 4 k cap. So magnitude of that vector will become square root of 3 square plus 12 square plus 4 square. So that is 9 plus 144 plus 16. That will become 13. Okay, so the magnitude will be this. So this is the additional formula. Okay, so this is how we incorporate the 3-dimensional vector algebra. After we've understood 2D last time and seen some questions based on that, now we have to just add the third dimension or the third axis, and along with that a third component, and rest of the things remain just like it was in 2D system. Addition, subtraction, etc. is done in the same way. Okay, people, so hope you have understood this properly. Yes. So with this, we conclude today's lecture. It brings this section to the end for today. And next time I'll be sending you another worksheet number 4. That will again have mostly component algebra based questions. Couple of questions also based on the 3-dimensional method we've discussed today. But most of the questions based on 2-dimensional components like the last one, but with additional level of difficulty. So next lecture we will discuss that, and then we will move on to the next part of vectors, which is products of vectors. अभी तक हमने addition and subtraction देखा है, but we will see that there are separate operations called scalar product and vector product of vectors, and we will discuss those in the next lecture after that. That's it for today. Thank you, people, and all the best.